So, hello, I'm Siddharth Yadav, and I'm a second year student at IIITD, and uh, this is like 5th of September in India, and we have officially completed the GSoC period, and this is about like post review on what I have done during this GSoC period, and what all thing are left, and what all thing we decided, and what all thing we didn't do. So here we go. So, what was this project all about? In brief, it was about cell segmentation, separating different cells in an embryo of C. elegans. So, this is kind of visualization of what we were trying to do. On the left side, you see this is the raw microscopy image of an embryo and C. elegans, and we were trying to mark down each membrane in the cell so that we can separate each cell and analyze it in detail. So what was were input our input were images. We decided it out of several other choices because they were really easy to work with, and kind of believe that they are future and will be more popular in the future because of their higher resolutions. And then as said before, we decided spin microscopy. And so this is kind of a few options we had, and we decided most of the work was done on the right one, and but they work equally kind of same in the middle one, but they are really like don't work. The algorithm we have developed might not work in this one. So uh, so input, we were thinking of proposing a general technique that can be applied to even fluorescence image and even BIC images, but we didn't reach that part, so we weren't able to do or reach. And so we decided to basically do try two types of segmentation: image processing based and machine learning based. It This project was kind of research based, and it usually involved exploring a wide range of techniques so that we could figure out the best technique that we could apply in this case. So we tried a lot of image-based processing technique, and name of them are mentioned here. And the details can be found in the GitHub repo, which is named at GSoC 17. And so out of clustering method didn't work out fine. The code of that and the result can be seen on the GitHub repo and the Python code. And this is level set segmentation. It is the thing that uh, we figure out work best for this problem. Active convert is kind of the same thing, which I figured out later. And this is also kind of same thing, but it didn't work out at all. And morphological and thresholding method. So there are notebooks in GSoC's 2017 repo, uh, which describes what kind of result we got from them, and you can also try them out easily. I will show you kind of. I will go. I will make kind of explore the code with you at the end. So this is the machine learning part, and we weren't able to arrive do the supervised machine learning part due to the following reason. Uh, uh, we weren't able to label data. Like, how could we label so much of data alone? So that was the basic problem, and that's why we didn't start with that due to the lack of time and lack of label data. Uh, but after this GSoC period is over, that is now I'm exploring machine learning techniques, and I will try different things, but majorly focus on unsupervised learning rather than supervised. So at the present, the output, the code pretty much outputs the marks the membrane of the cell and do the required cell segmentation as our aim was, but it is not that general and might require some tuning of parameters to give proper result. And this strike through part we weren't able to do due to lack of time. So the app we were pretty lenient about what technology we are going to use at the starting of the GSoC session. But as a session explorer, I got to know the power of ImageJ and how well, like how deep it is into like biomedical image processing. And I thought this was the best choice, and levels of every library was available there. So we stick to the default, like the title of the GSoC project as an ImageJ plugin. Uh, so the state of plugin at the present stage is like not that great. It is like a bit lacking the UX UI and the like. It's not that intuitive. Like it hasn't been yet delivered as a final like jar file that you can simply copy paste into your plugin folder and run it, or at a GitHub repo so that you can simply install it. So you need to actually run the Java file using Java C to get the result at the present moment. So we will be working on that part after we improve this algorithm part of this project a little more. As said before, we weren't able to do the UX UI part, and the plugin as a final user product is now ready. So you can, as a developer or as a kind of uh, a guy familiar with executing like a Java code with image libraries as their dependency, you can easily execute Java those Java files in the employee segmentation repo, and there is a opaque and intuitive GUI there, which through which you could enter input images and output images and get the desired result. And whatever code in the embroidered segmentation is present has been properly documented, and the documentation link is in the. I will show you the documentation link. So this is the like the code that I submitted, and I will. So let's explore it a bit. Uh, so so the research part of this project was this, and so as said before, this project was basically divided into research and development of plugin, and both have separate repos for the same. And uh, let's walk through that. So this is the research part of the project, and if you go into SRC and then you go to the Python, so here you can find the details of how thresholding and morphological operation work out. So it's taking time to load. So basically you will find what all we tried and what kind of result we got with this approach. And, and in comments you can see what problems we face. Uh, and then we have level set method, which was this was tried using oh, this is something else. So active contours. So this is what we have. Active contours and level set are kind of similar things, and we have in the end product embroidered segmentation, we have heavily used this concept to make to achieve what we wanted to do. So you can see what we got there, and you can easily download and execute these uh, and try out stuff if you want to. And so we also tried out motion based methods, so that so we observed that each consecutive frames only the membranes were moving. So we tried out motion based method in this, and this was something a bit of PCA and con encoder was one of, and data process were a few things that was trying to implement some unsupervised machine learning part. And validation is I so we were developing a validation algorithm so that we could, or benchmarking algorithm, so we could easily evaluate what kind of result we were getting, and their work can be seen easily here. And I guess yes, it is documented. And SRC, if you go to SRC and then you go to Python, there are a lot of other code, and it is documented as well. So, and a lot of data that was used in this project is present in data repository. I tried labeling a few images, which is also present in here. So you can see them if you want to. And there are few classifier that were trained using Vika trained classifier that you can use out of the box in our plugin, which require you to train a Vika classifier. And this is the image here, the plugin we were developing, and this is its documentation link. So you can easily explore what the stuff here. So, and the documentation corresponding to this code can be found here, and you can easily explore it. So that is pretty much what I did this GSoC.
Okay, that's very good. So you went through the project, what you didn't accomplish and what you did accomplish, and then you showed us a little bit of your gist repo, which you submitted to the Summer of Code project.
Yeah.
So what are your future plans for the project? What would you like to accomplish with it from here on out?
So the future work is usually divided into two parts. One is research, and second is ImageJ plugin. So ImageJ plugin would require work on UI and UX and kind of development of tutorials so that it is easily available to the community. While there is another part which is kind of research based, in which we have to tweak the algorithm so that we can get exactly out of it. And then I guess there is also a third part, which is a major, which was the this thing we are going to do after this project is like quantification of segmentation, getting data out of this segmentation. So I guess those three are the major steps. So from now on, I'm going to focus on the research based thing, and if we get good result in that area, I will be developing image. I will be transferring them into ImageJ code after that. So, and if you want to contribute, contribute in this project, I guess it is pretty simple to start with, especially the ImageJ plugin part. And if you are already into image processing or machine learning, you can contact with me, get in touch with me or the mentor. So we can guide through how to get started and what all stuff would you need to make a useful contribution. And I guess it is pretty easy to get started with the ImageJ plugin part. You just need to go through a few big tutorials on how to get started with developing an ImageJ plugin. That's it.
Okay, that sounds good. Anything else you'd like to add, or?
I don't think so. It was like a wonderful experience working in OpenWorm. It was my first experience in the open source community, and like interacting with people which I have never met online, and working with them, and it was like fun. And I really wanted with the community. Contributing to and seeing going through the other project in the same organization. Due to time restriction, I wasn't able to really give that much contribution, but I really like contributing to small stuff. And I guess that was more important than all the learning and working I did. Just GSoC, the feel of working in actual open science and open source communities. So that was the chief thing I got from GSoC, apart from the money.
Oh, yeah, that's always good too, though. All right, well, thank you.